Greetings, everybody. I hope you are doing well. Today, I'm going to walk you through the debrief of the lab you did last week. And if you didn't finish the lab, it's okay. You did enough of the lab to be able to respond to the questions that I'm giving you. If you want to get the remaining sheets that you didn't get, the sub has them. There are 8 sheets in all, and that way you can look at what was on the sheet and what was supposed to be done. Now, you're going to complete this as a small group, but everyone has to answer their own questions on Edpuzzle. And so the way I usually recommend doing it is you are with your group of 3 or 4 people. Everybody has the Edpuzzle running on their iPad, but only one person has the sound turned on. And then when it pauses, you stop and discuss, and then everybody answers their own, and you keep moving on. So the first thing that we are going to look at are trends in the motion. And I want you to find a piece of scratch paper because you are going to be writing down a couple of things. And if you have the visual image in front of you, it will be much more powerful. As you're going through this, you're going to be thinking, probably this is easy, this is trivial, but if you get these visual images in your head, they are actually pretty profound by the time we get to the end. So I didn't number these, but basically on your sheet, the description, speeding up positive direction, this was 1 and 2. Speeding up negative was 3, 4. Slowing down positive was 5, 6. And then slowing down negative was 7, 8. And just so you can remember what each one was. The first one, we had the motion detector at the top of the ramp, and the car started at the top of ramp and we let it go down. Second one, motion detector at bottom of ramp, carts start at top of ramp and go down. The next one, motion detectors at the bottom of the ramp, the cart started at the bottom and you pushed it up and it stopped at the top. And then finally, the motion detector is at the top of the ramp, car started at the bottom, you gave it a little push and it stopped at the top. So I want you to kind of stop the video, and again, you can consult with your friends. There's not going to be an entry on this one, but I want you to actually draw the direction of velocity and the direction of acceleration. So like I said, pause, write these out so that you have the pairs for each of the 4 experiments right in front of you. Okay, so now I want you to stop and talk about what pattern do you notice with the arrows for speed up. So stop, put in your entry, and then you can go on. All right, the next one is, what pattern do you notice with the arrows for slow down? Again, stop, pause, put your answer, move on. And then finally, what effect did changing the reference frame have on the motion of the cart? Discuss, put your answers in, and then move on. I'm not going to give you the answers or insights to these until the very end because I think that you will be able to figure out on your own what is happening. All right, so the next thing that you want to do is you want to, for the same 4 experiments, I want you to write the signs for a velocity and acceleration. So again, stop the video, write the 4 pairs of signs so that they are in front of you. Okay, so looking at the signs, I want you to identify what pattern do you notice with the signs for speed up. So pause, discuss, enter. And then what patterns do you notice with the signs for slow down? So what effect did changing the reference frame have on the description of the motion of the cart? So description of motion includes speeding up, slowing down, as well as the sign of the direction or the direction the object is moving. And then why is it important to have a clearly identified reference frame? All right, the next one is sketch the graphs. And again, I want you to look at the same 4 experiments and sketch the position versus time. And then I want you to indicate whether the slope is increasing or flattening. So stop the video, write your stuff, and then start again. But like I said, you want to have the 4 pairs of information in front of you to help you answer the questions. Okay, so what patterns do you notice with the graphs for speed up? What patterns do you notice with the graphs for slow down? What effect did changing the reference frame, which was the position of the motion detectors, have on the position versus time graphs of the cart? Oh, sorry for the 2 those. If you are looking at position versus time graphs, what key feature shows you the object is slowing down? So the key feature is, in case you didn't get it, is flattening out. Because for position versus time, flattening out means the graph, the flattening out means the object is keeping the same position over a duration of time, and that is stopped or slowing down. Okay, we're going to sketch some more graphs. This time I want you to stop and sketch the velocity versus time graphs. And I want you to indicate when is the velocity 0. And so circle the answer, or you can write it on your paper. I guess circle was dumb because guys don't have a handout. But again, write all 4 pairs of the velocity versus time and when the velocity is 0. So what patterns do you notice with the graphs for speed up? What patterns do you notice with the graphs for slow down? And then what effect did changing the reference frame have on the velocity versus time graphs of the cart? Again, sorry for the double does. If you are looking at velocity versus time graphs, what key feature shows you the object is slowing down? So the key feature that shows you the object is slowing down is that the graph goes towards the velocity equals 0, or the x-axis. All right, so we're going to wrap this up, and I'm going to give you a table, and this is kind of the take-home message that is really important, that will just give you some conceptual foundation or insights for asking questions or for answering questions in the future. So it's not like I'll ever explicitly ask you this question, but it will just be part of your background knowledge that will help you feel more comfortable at answering questions. And so we have 2 situations where we have speeding up and slowing down. And for each of these, we have velocity and acceleration. So some of you, have probably already figured out what is the trend for speeding up and what is the trend for slowing down. So for speeding up, velocity is plus plus or minus minus, and for slowing down, it's going to be plus minus or minus plus. And so the big take-home message is that when velocity and acceleration are in the same direction, I don't need to write this out. When velocity and acceleration are in the same direction, you have speeding up. So you can speed up negative, you can speed up positive. But when they're in the same direction, they are speeding up. When they are in opposite directions, remember from the sign, Then we have slow down. And so, like I said, I won't necessarily ask you this question explicitly, but knowing this will give you insight.